talked about action potentials and how the action potential gets propagated down the axon, right, to the terminal button. And what exactly happens at the terminal button? Our goal at that end is to get a neurotransmitter released so that it can go to the second neuron and deploy that guy. So what events happen? Can you list them in order? Yet? Okay, so we get an action potential going down to the terminal button of the nerve. What happens next? It triggers what?
Does the calcium go in?
Okay, so it causes calcium voltage gift channels to pop open. And calcium does what? It goes into the cell, right? And then causes what to happen? Right, it causes these vesicles containing neurotransmitters, and it's usually going to be acetylcholine, right, for what we're talking about, to release, to exocytose the neurotransmitter in the synaptic cleft, right? And then what happens? What happens? Once the neurotransmitter is in the synaptic cleft, where does it go? Does it just hang out there?
No, it goes
Binds
to
to what? A receptor, right? And that receptor is a ligand-gated channel. Perfect. So it binds the receptor, and then what happens? The receptor, it pops open, right? It stimulates it to open. Okay? And then what goes into the cell? Sodium rushes in to that postsynaptic cell. And what happens then? Right, it depolarizes the postsynaptic neuron. And you get an action potential. And then this action potential gets generated down the postsynaptic neuron. Okay? So basically what you have is a nerve communicating with another nerve via a neurotransmitter. Okay? This guy gets excited, produces action potentials that gets generated down the axon, and to communicate to the next nerve, to get the second nerve excited, you have to release a neurotransmitter. Okay? So you can't have an action potential cross the synapse. Okay, it has to be a chemical, it has to be a neurotransmitter. So you have nerve, neurotransmitter, excited, the secondary nerve. Okay? Any questions on that? Okay. And how does this action potential stop? These neurotransmitters, as long as they're in the synaptic cleft, will keep binding to those receptors and popping those receptors open, or keep producing action potentials in the secondary nerve until these neurotransmitters get scooped back up. They either get broken down by the postsynaptic neuron, or they get scooped up by the presynaptic neuron. Here's your little transport protein right there. Okay? So the transport protein is going to pull the neurotransmitter back in. So this neurotransmitter gets sucked back into the end of the neuron, and therefore it's not present in the synapse. If it's not present in the synapse, it can't excite this guy. Does that make sense? Yeah. Let's talk about your nervous system. So when you took anatomy, you spent some time learning your central nervous system, the 12 nerves, right, your cranial nerves, and whether they were sensory or motor or mixed. So for central nervous system, and I'm not going to expect you to know all those because you should have already memorized them. You have two parts to your nervous system. You have a central nervous system and a peripheral nervous system. Central nervous system consists of what? Your brain and your spinal cord. Okay, and peripheral is what? Everything else. So everything outside of the spinal cord is considered peripheral nervous system. Perfect. Peripheral nervous system, everything else. Whoops. As a side note, remember, sensory neurons are afferent neurons. They go to the brain. Okay, so this week in lab, Tuesday you did the sensory portion, today, Thursday we'll do sensory portion. When you're touching something, you're depolarizing sensory nerves or nerve endings. They're sending depolarization or action potentials to the brain. These sensory nerves are going into the brain. They're considered to be afferent nerves. The brain interprets it, and if you need to, it will activate motor nerves. Motor nerves are going out of the brain. You can think of them as exiting the brain, so they're efferent, right? And those guys are going to be your motor nerves. An example of a really simple synaptic loop is, let's say you touch a hot plate, okay? Sensory nerves can then go to the spinal cord. It synapses once, goes back out to your motor neuron, and activates your